I'd like to give you a little how-to on how to weld architectural bronze 385. It's actually considered brass, but I'll be showing you how to TIG weld on direct current using aluminum bronze TIG filler rod. This is not brazing rod, it's TIG filler rod. Big difference. The color match comes out pretty good. I'll show you and grind some later, but I found a way to make it work using a pulse setting. I'm going to go over machine settings in just a second, but I'll show you how to set it for pulse setting. I'll show you how it runs on just direct current without pulse, and I would also like you to hear the difference between them. And that's the best way I found to do this, is listening to the hiss and the crackle when we're welding. So, you don't need a fancy machine. This is an old AHP 200X. I've got it set to about 141 amps. There's no pulse setting right now. I've got my gas flow running at about 15 to 20 CFH. Air-cooled torch, gas lens, that's optional. But I'm going to run one straight. We're going to do just a straight run here. I'm going to tack it first without the welding lens, so you can see the smoke and the nastiness of it. I believe it has tin and lead mixed with copper, which makes it a brass alloy. So you definitely do not want to breathe this stuff in. But let me get set up and we'll show you tacking this stuff. One thing about this stuff is it's very dirty, so don't count on using your consumables for anything after welding this stuff. Clogs up the screens, constantly getting on the tungsten, so there is no keeping this clean in the process. So as long as you've got a sharp tip, you should be okay. And throw these out when you're done, because they're contaminated with lead and zinc and whatever else is in there. Very dirty. You could hear the crackle. But the soot covers it. We'll get into welding one next. This is no pulse, direct current. Lots of crackling, lots of spatter. Now let me switch to pulse. Here's the pulse side. Pretty crackly, or ripply, but you can see it's built up high, enough to grind flat. That's our direct current. Again, real ripply. So the stuff is real tough to make look smooth. Now with pulse, I'm going to run a fillet weld. Now when running a fillet weld, you want to concentrate on the top part of the fillet weld, or else you get severe undercut. See, even with doing that, it likes to cut into that top. We'll now run just direct current with no pulse, and we'll fill this 90-degree angle up. We'll get an arc shot of this outside corner. I notice without pulse, it likes to heat up extremely fast. You can just sink right in, so the pulse helps control that melt away. I had to manually pulse that, or else it just wanted to explode on me. You can see the mess this stuff makes. I've switched back to pulse to help control the melt away and try to get a cleaner undercut on the top of the fillet. And it has given me a much nicer tie-in at the top. Didn't get undercut on that one. You can see the first attempt I did of a fillet, that top just totally burned away because I was totally concentrating on the bottom. On the other side, I started working towards the top a little harder, which is this side here. Still some undercut. Not great, but better. But on this one, I switched completely to the top with pulse settings. And now, that one flowed in very nice at the toes. So pulse was a great help in concentrating on the very top of the weld. It's paramount. So how about color match with aluminum bronze? Color match is almost perfect. It will chemical treat a little different, but silicon bronze leaves a much oranger brown than this golden yellow. So how strong is it? I ground off the three sides. They're not even properly filled in our fillet here. So let's give it the test. Well, I'd say that's holding pretty well. Bent the steel pretty good, or the brass pretty good. Hope this helps.